It's 11 o'clock. I believe we're on. Welcome, panel, and welcome everyone who's joined on time. No doubt there'll be people still joining us. So let's give it a minute and just make sure we've got a good contingent joining or joined. So we have just over 140 registrants. So lots of people to join, fighting to get on. That's good. Okay. Let's get started. I think we've got now, yes, quite a good audience and eager to get started too. So I'd like to welcome you all. Good morning or afternoon, evening, depending on where you are. My name is James Rosenshine. I'm your host for CUI Over Coffee. Some of you have already been part of this series. Some people are new. So just to explain, CUI Over Coffee aims to promote online discussions within the asset integrity community to exchange information, experiences and ideas. We do have the pleasure today, a distinguished panel. We have Marta Mahidano. Marta, hello.
Hello.
Hi. We also have Bill Hedges. Hello. Hello, Bill. Can't hear you.
That's because I muted myself. Good morning, everyone.
Well done. That's at least we now know you're able to speak and we can hear you. And Claudia Pinon, hello.
Hello.
And finally, Shiraz Enisser, hello.
Hi.
I will give you all a chance to introduce yourselves shortly. So welcome. So as a reminder, last season we had 8 online sessions which stimulated healthy debate and insights into corrosion under insulation. In our season 2, we introduced leading companies within the ecosystem who are talking about what exactly they're doing now to help combat CUI. Because quite frankly, it's still a bloody pain for us all, and we need to address it in a collective manner. The last session, we had the pleasure of Saudi Aramco and Cognite join us in April, and they looked at the asset integrity management challenges from a holistic perspective using systems thinking, and with improved collaboration across the various different players in the ecosystem. So the common thread for us all, we need to change. CUI is still a problem. What can we do about it? But today we have a really nice twist. We are delighted to celebrate Corrosion Awareness. Corrosion Awareness Day was back in April, and our very own Claudia Pinon has actually drawn some inspiration from her course with the Institute of Corrosion to actually continue to raise awareness in corrosion and from her perspective. Claudia, please introduce yourself and share some of your passion about our subject today, please.
Hello, James. So yes, I have been working for Corrosion Radar for 2 years already. Actually, today and this month is my anniversary here. Thank you. And yeah, so I studied industrial chemical engineering, and I converted to a corrosion engineer here in Corrosion Radar. And I discovered this big problem here, the corrosion problem. So now I'm involved in different activities to promote corrosion to young engineers and of course corrosion awareness. So yeah.
Excellent. Now it's great, Claudia, for you to come up with this idea for this session, and we're looking forward to it. So let's also give the opportunity for the other panelists to introduce themselves. Marta, please.
Yeah, so thank you for having me today. It is a pleasure for me to be part of this great initiative under the frame of the Corrosion Awareness Day. I'm Marta Medano, and I'm working in the group of characterization, corrosion, and degradation of materials at the University Complutense of Madrid. My research is focused mainly on the development of multifunctional coatings for corrosion protection of light alloys. And Well, I'm also the chair of the Corrosion and Protection Task Force at the Spanish Society of Materials, and also the chair of the Young EFC, which is the Young European Federation of Corrosion. So
Excellent. Thank you, Marta. And Bill?
Good morning, everyone. Pleasure to be here. My name's Bill Hedges. I guess I'm the old person on this call. Had a fantastic career of 30 years in oil and gas, mostly working with Exxon Chemical, and then the last 24 years with BP. In BP, I've had assignments in Houston and Trinidad and Alaska. And Alaska is probably quite important relative to this call because we probably had in Alaska the largest CUI integrity program in the world. So a huge CUI problem and program to deal with it. I left BP at the end of last year to become a consultant and also begin the gentle retirement process. So I'm quite happy not to be in full-time work anymore. And I'm also currently the president of the Institute of Corrosion in the UK.
Fantastic. Great to have you on board, Bill, and hope this is something nice for you to do now you're retired. And finally, last but not least, Shiraz.
Thanks, James. So this is Shiraz Nasser. I'm the co-founder and CEO of Corrosion Radar. I'm halfway from Bill, so I've been 15 years involved in asset integrity related matters. And at the moment, I'm living my dream at Corrosion Radar, developing a new technology, solving a big problem, which is corrosion, biggest failure mechanism in the world. And we are focusing more on the CUI, corrosion under insulation, and hopefully making a contribution and enabling a more greener, more sustainable way of generating energy and leaving a cleaner world to the next generations.
No, fantastic. And it's nice that you've got that mission and dream that you're following. Okay, so let's just get straight to the topic. A life of a young corrosion engineer, which is a hot subject given the challenge with CUI, not just as part of our traditional energy industry, but also as we are moving into new energy and with the energy transition, CUI is still not going to go away, and it will continue to surprise us if we don't detect it before it causes and leads to damage. So we need talented people. We need young corrosion engineers to help us with the fight. So I look forward to opening this debate. Let's just crack on with some general housekeeping very quickly. We've got probably another 30 minutes of debate, and then we'll open up with some questions and answers. We even give people who are really keen to voice their question, we give them the mic. Our intention is to keep it high level, not to try and go into too much of the detail, but of course with some of the questions and answers we can do that afterwards. The session is recorded and will be made available to all registrants, and at some point will be made available on YouTube like we normally do. So without further ado, let's start by making sure everyone's relaxed and has got their coffee cup, and wherever you are, if you're drinking another hot drink, let's just enjoy a relaxed session and debate. So thank you. Let's start with the opening burning question, and I'm going to look at you, Bill. Apologies for this because a bit tongue-in-cheek, but we still have a problem with CUI. We're still talking about it over all these years. So is it the case that the young corrosion engineers decades ago got it wrong? and maybe you can reflect on that and tell us about how you started out with your career, and what was it like? I'm sure it was different to what it is now.
Yeah, wow, couple of big questions there. Thank you. Great to see so many people on the call, and they're quite far afield because I recognise. Hi, Richard in Indonesia. Good to see you from BP there. Wow, look, I'll come to whether we got it wrong, right? So I don't feel so bad right at the beginning. Wow, young engineer, that's a long time ago for me, but I would say things were very different. You know, in some ways very different, in some ways the same. I think I'm going to think of three things that are probably a bit different. When I started out as a corrosion engineer, it was the beginning of the transition to widespread use of computers. So believe it or not, when I was young, there were no such things as laptop computers. There were no mobile phones. Sometimes we would still use letters to communicate. We would put documents in the post and send them off. And can I say this? You know, we think we improved, don't we, right? But, you know, letters gave you thinking time. You'd send your report off and you could stop and reflect on that a little bit. Today, someone will send me an email in the morning, and if I haven't replied in the afternoon, they send me a text to say, did you get my email? And I'm like, give me a moment here, guys, right? So, you know, in some ways we've improved. In some ways, maybe we've made life more difficult for ourselves. Thinking of reports, another way, maybe things have not improved so much as today. If I send a report to someone, I get 100 grammar mistakes back and commas in the wrong place. In my early days, we used to send reports to the typist pool, and people would type them out. And if you went back and you said, you see this lovely page you've typed out for me, that comma's in the wrong place, would you retype the whole page? A really experienced typist would look at you and say, go take a running jump, Bill. I am not going to spend all my time making it look perfect. It's good enough. So some things have changed for the better. Maybe some things are a bit different. So the transition to computers would be one thing I would point to as being very different from when I started. Another thing I would point to in my history is in oil and gas. I think I might be right for other industries, but in oil and gas, the second thing I'd say is we saw a transition to business being based on data. So human relationships are really, really important, and they are important today, and we should never underestimate the value of relationships. But when I started, a lot of business was done in the pub, and it was done over dinner, and it was like, Bill, I really trust you. You're a good guy. Yeah, I'll agree to do this piece of work, or I'll buy that chemical from you, or whatever. And in that early period of my career, we saw a transition in corrosion to people talking much more about data and wanting evidence for why they would make a decision. So I would point to a transition of sort of business done primarily based on relationship to business primarily based on data.
Yeah, that's interesting. And Shiraz, you've had half the career of Bill, but maybe you can also relate to the relationships and how that is still important, but the need to also get our heads around data too must be quite challenging.
Absolutely. I mean, relationships, I think whatever sector we are in, whatever problem we are solving, it is very important to have that network. Not only to understand what we are talking about, because for corrosion, we are solving the problem, but we are look at it from a different perspective. For example, if you are an end user or you are in the supply chain, you will look at it in different ways. So having that network and that understanding is very important. But let me go back to corrosion in general, like a path for what a corrosion engineer look like. And I know that a lot of young engineers listening to us today, and I want to say there is no one path to be a corrosion engineer. I mean, I started with myself. I started as a civil engineer. Then I did my PhD in mechanical engineering, focusing on non-destructive testing for pressure vessels for certain failure mechanism. And then I moved to the Welding Institute, where I worked more in innovation, but focused on NDT monitoring for asset integrity related issues and different failure mechanism. And this is where I learned, working with Shell, BP, and other oil and gas companies, that corrosion is a big problem. Corrosion is a problem that we had in the past, we are having in the present, and we will still have in the future, whatever source of energy we are talking about. And for me, through so from civil engineering to NDT to corrosion, but also through different angles. I worked as a researcher, I worked as a technical person, in a management, and now in entrepreneurship. So corrosion is a multifaceted problem, and you can contribute to it from a different angles in terms of where you are at your career, in terms of skills, because you can always, and I think the young generation have really, really big opportunity. Back to the data that Bill just mentioned, it is very, very important going forward. How can we use what we know now from a technical point of view and bring that in solving this big problem?
That's really interesting, and you draw on your rich experience in academia and also the corporate world. And Marta, I understand that you completed a PhD back in 2011, and soon after you were internationally recognized for your research in corrosion. So how was it for you building a career focused on corrosion within academia?
Yeah, well, honestly, it was not always easy because it is crazy competitive, but at least for me, it is totally worth it. In my case, I did my PhD at the University Complutense of Madrid, and then I moved to Germany, and I spent there 3 years, and then I came back to Spain. And during the whole time, in my path was based on individual fundings obtained in competitive calls. So I could say somehow that I'm climbing the university career ladder as a researcher, bringing my own funding projects to the university. And this is a way to build your career as a corrosionist here in the university, because with the time you get a permanent position. For example, in my case, if everything goes right, that I hope so, and this opportunity for me to get a permanent position is coming in 2 years when I finish my current contract. So that is my experience building my career based on my own funded projects here in the university.
So am I right in saying you got plenty of support back then from professional bodies such as EFC, or was it slightly different then?
Yeah, well, for my PhD, I got a fellowship from the university, and I also get something that is very important, that is funding to spend predoctoral stays in a foreign country. In my case, it was at the University of Cambridge there in UK. And after my PhD, I got the Humboldt Research Fellowship for postdoctoral researchers, and I moved to Germany, Helmholtz-Zentrum Gestacht, for 3 years. And then I came back to Spain also with public funding. In this case, Juan de la Cierva Incorporation Fellowship. And after 1 year, I got a national project. I was the PA, principal investigator. And 2 years ago, I got the Ramon y Cajal funding. That was my target the whole time. Because after you get this kind of funding and contract, you get a permanent position at the university. So, okay. Yeah, so basically I got different entities funding my projects.
So you sound like you got some really good, rich experience in starting your career in academia. So if we were to reset, and I always like this zero-based thinking, if you, based on what you know now, what would you actually do differently? What would you say to young corrosion engineers starting out in academia?
Yeah, that's a tricky question because I really like where I am right now, but I think that I probably wouldn't change anything about the steps that I follow. But I do think that I might change the energy. I mean, my emotional state during the early steps of my career, in particular, trying to find my first postdoctoral stay, because I was really super stressed. And I think that it was because I couldn't see what I see now, that it is that the world is full of possibilities. and we are able to adapt very fast to a new situation, like new job, new country, new language, new people, whatever. So we shouldn't be afraid of changes, because actually a change, it is an opportunity to grow. So in other words, like if you don't get what you want, what you have been planning in your mind for years, don't freak out, cry a little bit if you feel like, but don't get stuck and move fast to another thing.
That's interesting again. I mean, if we come to you, Claudia, is that agile approach, is that what young corrosion engineers like yourself are taking? You know, are you looking to adapt and change and drive change? And can you resonate with some of the experiences from the other panelists? Does that resonate well with you? And
Yes, I see. Yeah, I see that. Yeah, the path from everyone can end up in the corrosion field from very different ways. As Bill and Shiraz was saying, in my case, I always liked chemistry, but I wasn't sure what I wanted to do. So I decided to do industrial chemical engineering because it's a broad field. Then I decided to, I mean, in my degree, when I studied some materials science, but I wasn't, then I specialized in environment, so it's sustainability and environment. So it's not very related with corrosion. But then when I finished, I wanted to travel and learn new languages. So that's how I ended up here in Cambridge, where I started an internship in corrosion radar. That's how I become a corrosion engineer and how I discovered this world. So yeah, everyone can end up in this in very different ways. And also, speaking about what Bill and Shiraz were saying, I think in my case now, I'm studying a master in big data and data science, because I think the role of big data will only grow in this field as to detect corrosion in the pipelines. That's something that is a skill that can help a corrosion engineer, and I find it very, very exciting.
Okay, so that's what's exciting you now, is it? The big data aspects and how that can be applied to some traditional problems.
Yes.
Okay, interesting. So just drawing on what you just said, how did you move from successfully transfer from academia to the corporate world? Because you know, Marta is still in the academia world, which is great, and she's enjoying it. I imagine there are people that are wanting to make that change and shift to the corporate world. So how did you do it? You know, what worked for you?
Yeah, so try to find a company that gives opportunities and start with an internship is the best approach. Even if it's a small company, you don't need to go, you know, and opportunities. Try to find opportunities, and that's how you can start something very small. As me, I didn't know about corrosion a lot, but then I learned everything in corrosion radar from almost zero. And also trying to participate or trying to find organizations as ICOR or the European Federation of Corrosion and participate in their activities, and all of that will help you to move.
Yeah, okay, that's good. And so people who are listening in that may not be in the corrosion domain, doesn't mean to say you can't you know, leverage your skills from a material science or engineering academic world and take that punt and join a young or you know, mature company, find those internships, and it sounds like then opportunities open up, like for Claudia. So that's good to know. Now, so that leads us on to, or leads me on to thinking about the present, and I'm intrigued about what the other panel members think about what it's like for young corrosion engineers now, like Claudia, and that link between academia and the corporate world. Shiraz, you might be able to draw on your experience. You mentioned you worked for the welding industry. To my understanding of what they call themselves, TWI. It's a good combination of scientific research and innovation and access to the corporate world. Can you elaborate on that experience, because it sounds really interesting to me.
Yeah, you are right, James. But actually, my experience at TWI was exactly that. So I used to lead what they called Structural Integrity Research Foundation, which with the main objective to bring academia and companies to work together in solving asset integrity related issues, and corrosion was a big part of that. And Corrosion Radar, I have to say, is another example of that. We are a spin-out from Cranfield University. So there was a lot of research and work has been put in to bring a new innovative solution to solve the CUI problem. And me and my co-founders, with our industrial experience, we decided to bring that to the market and make it available to companies in order to help solving the corrosion problem and CUI problem. And I think, honestly, we are at a time where thinking out of the box and being creative and challenging the status quo, it is the right time. And with the pandemic, with the digitalization booming and accelerating across different sectors, in the cost of enabling technologies is coming down, wherever that is a computer to run a big model, wherever that is an IoT, for example, device, that all contributed to probably a move towards solving things in a different way, and corrosion is no exception to that. And back to Bill's actually comment on speed, and I think agility is a big part of that. I think being agile, being thinking out of the box, I think that's what, especially from a corrosion point of view, we were thinking in the box for a long time. Now, with everything happening around us, I think we are in a good position from young engineers, because they are bringing a new way of solving problems, with the people with more experience, because that is very important. Learning from the past is very, very important. Combining that together, also bringing different industry collaboration is very, very important. That is from the academia, from the end users, from any people involved in the supply chain is very, very important to, as I said, challenge the status quo, because that's, especially for corrosion, is being with us for a long time. We need to do things differently. Yeah. And young engineers have a big role to play in there.
So it's great to see a fresh influx of young engineers helping to challenge the status quo. I think it's quite easy for people who've been doing things the same way for 30 years, are quite happy just not to change. And that agile approach, that creativity, I think is great for you young engineers to bring to our industries that have tackling CUI. So Marta, where's the role of the EFC play now to help young corrosion engineers?
Yeah, so we have to take into account that the European Federation of Corrosion, the EFC, was founded in 1955 and starting only with 9 different countries. And what do we have now? We have a federation of 41 organizations based in 25 different countries in Europe and beyond. So it is great to see that the EFC has grown and diversified with the time. And I would like to highlight a very important milestone that was the creation of the Young EFC in 2016. The main aim was to support the young corrosionist engineers, researchers, and how can we do it? Well, we think that it is very important to create and to have the feeling of community. So young corrosionists are welcome to become a member and to join the different initiatives. For example, you can apply for awards, grants for traveling, to do some research in another place, or to visit any different industry. Also, we conduct webinars, and everything that we do there it will help you to build your career and also your network, because that is going to be the key for your future. So you can follow us, for example, also in the EFC LinkedIn, and be the first to know what's going on about these activities.
That's good to hear. Excellent. And I like the fact that you now have a global reach, because Shiraz mentioned about learning from not just different industries. We need to learn from different regions as well, and have that collaborative approach. So hoping EFC are really driving that forwards and sharing information and creating that network for young engineers to leverage. So that's great to hear. Bill, so I mean, what do you see now for corrosion engineering? Is it revolving around the same topics, or are we now focusing on new problems in the new industry, or old problems in the new industry? I mean, obviously, energy is now going through a significant transition. So, what do you see that's changing?
Well, yeah, great question. The energy transition is crucial. I've worked in oil and gas. We haven't done everything right, but oil and gas is changing. And if you look at the reality of life, oil and gas, for example, is going to be around for at least the next 50 years. So we need to improve that. And that means less leaks, because we can't, in the past, we thought it was acceptable to allow things to corrode. And then when it gets to a certain point, you can repair or replace. That's perfectly acceptable from a safety and an environmental practice. But if you think about the energy transition, it's totally unacceptable from a position of having to make new materials, make more waste. So the energy transition is absolutely critical, and we're going to see phenomenal opportunities in areas like wind, solar, nuclear, carbon capture. We are going to produce CO2, right? So we're going to need to capture it. Corrosion engineers have phenomenal experience on dealing with CO2 corrosion. That's going to be applied going to carbon capture. We're going to move to the hydrogen economy. We're going to need to transport hydrogen in pipes. We've been transporting and dealing with corrosion in pipes for many, many years in many industries. All of those skills are going to be really critical. So I just see phenomenal opportunity going forward. You asked me earlier, James, about have we messed up? Has my generation of corrosion engineers messed up? And if you're a pessimist, you say yes. If you look at for the last 50 years, the cost of corrosion has been 2 to 3% of GDP forever, right? We haven't brought that down. So maybe we haven't done a great job. I maybe would have a different view and say things have got much harsher. We're dealing at higher temperatures with corrosion, higher pressures, more exotic materials. We haven't brought it down, but maybe we haven't made it worse. So we've kept things going.
Yeah.
But we need to improve. And I think that's the great opportunity that's been mentioned by Claudia, Marta, and Shiraz. Is a phenomenal opportunity to improve and bring costs and environmental damage down.
Yeah, and that's it's a very good point in terms of yes, there are oil and gas still has a large part to play over the next 50 years as we transition to new energy. Some of those assets we need to make sure that we maintain them and optimize production in those assets for years to come. Some are at the late life stage, but now we're talking about potentially repurposing some of these assets for, you mentioned carbon capture, storage and hydrogen production. So if that's the case, and we are trying to transition to new energy in a more cost-effective way, we don't want to be reinventing the wheel, reinventing infrastructure. So we need to look at things now and look at things differently in terms of how we can address UI to extend the life of these assets. So that's a very, very interesting point. So thinking about the future as we move to a low carbon world, what does this actually mean for budding young corrosion engineers? Marta, what are the skills required for the future?
Yeah, well, I think about in the future, it's going to be very important, the international cooperation, technology, and also environmental regulations that for sure they are going to play a very important role. So in terms of research topics, I would say that important skills could be anything related to big data and machine learning for prediction of corrosion. And also, I think the novel ideas for corrosion protection using environmentally friendly techniques that could be alternatives to some toxic that we are currently using in industry. And then in terms of more personal skills, I could highlight that it's going to be important to have great management skills because they are going to be very necessary, such as planning, communication, decision-making, problem-solving, everything about that. And something that it is getting more and more attention with the time, that it is emotional intelligence, because it is true that we all want professional success, who doesn't? But we also deserve to be happy in our work environment. So this is something that I think that it's gonna be also important in the future.
Okay, thank you, Marta. So that's good food for thought, and we all need to continue to develop our skills and think about the role that we can play in the future. And talking about roles for technology companies, Shiraz, like Corrosion Radar or other technology companies, you know, what role do they have in helping the workforce of the future?
Yeah. I mean, technology companies, including Corrosion Radar, are playing and will be playing a very important role going forward. And if we bring that to a corrosion is a process problem. So as I said earlier, it has multi-facets. And what Marta said, there are actually three factors to that. There is the environment, there is the collaboration, and there is the technology element. And I'll give Corrosion Radar as an example. I'm sure there are a lot of tech companies doing the same thing. For example, from an environment point of view, our vision is how we can enable a safer and a more sustainable world. You could do that in many ways and in many directions, but our contribution to that is how can we solve or help solving this issue with corrosion. And Bill mentioned 2 to 3% of global GDP. That's a lot. And also the environmental impacts, what we had before and what's going forward. So I think that should be a big driver for companies contributing to a solution for this issue. From a technology point of view, in Corrosion Radar, we are blessed to have amazing engineers. And our approach is, what problem are we solving here really from a CUI point of view? What is the basic problem we are solving? And what we are really focusing on is that corrosion under insulation is very unpredictable. There are two simple questions we need to solve: where and when this problem can happen across our assets, and then we take it from there. And I think thinking out of the box a little bit and trying to see what we're trying to solve, that is really helps in building up the right technology. And the last thing, as a tech company also, our contribution to that in a way is the collaboration. Be open to collaboration. I think especially the oil and gas sector worked for a long time in silos. And if we do not encourage collaboration, I think we will be talking about the same topic in the next, next decade. So collaboration is very, very important. Sharing information is very important, not only for the sector, but also for the next generation and next energy, for the energy transition. Yeah. Learning from that. It's not only solving, but also the learning aspect to it.
So you've heard it, Claudia. You need to get out there, start collaborating, start making, using your creativity to drive change. Okay, easy. I mean, just to finish on this great debate, and there was some good questions, and I think some people might be raising their hands and wanting the mic. So, Claudia, as a young corrosion engineer, what's going to inspire you in the future to basically stick with this problem of CUI?
Yeah, so I really relate with all what you said. For me, are two main things. is how related is corrosion with the environment, like causing waste of valuable resources, loss on efficiency, and much more. That's the first thing. And then also how the way to solve this old problem is evolving with new technologies, different required skills. So those are two things that really motivate me. And also inside CR, I like to work in a dynamic environment where I do experiments in the laboratory. Then I am involved in different projects as the starter pack that is for companies to go towards adopting a predictive corrosion monitoring approach. And I don't know, I think all of that is something that really motivates me for the future. And yeah, so.
Great to see that motivation shining through. Thank you, Claudia. So we're drawing to the end of the actual debate itself, and I mean, I will wrap up. But as I'm wrapping up, anyone that has a burning question, you can use the mic, and feel free to continue to ask questions using the chat and Q&A. So I always like to wrap up by asking this question. So can you just give me that one thing that you want people to go away with and remember and take with them and use? So let's start with Marta. What is that one thing that you want people just to go, right, yeah, I remember this session and that's what I need to do?
I would say possibilities and thinking outside the box.
Ah, yeah, I like that. Yeah, that was good. I think Shiraz mentioned thinking outside the box. That's a good one. Shiraz?
I want to say corrosion is cool. If I convinced my 11-year-old daughter that corrosion is cool, I think it is. And there is a big space for young engineers to really contribute in solving a massive problem. And that's all aligned with all the good things also that hopefully also inspiring the young engineers in terms of environment. It's directly linked. So if you are thinking about or you are involved in corrosion matters, think about it that way. No, not only the failure side of it. It's what it is and how it contributes in a much bigger scale.
Yeah, that's a good point. And just reflecting on myself, I come from a enterprise digital transformation perspective in oil and gas, which covers so many different areas. But we're always looking for a problem. We're like, right, we've got this great technology, give us a problem. And it was refreshing for me to join a company that are looking at addressing the problem and then applying the solution and the technology and the creativity to that. So it's interesting to say that, Shiraz. And Bill?
Well, some great points have been made already. So I'm going to speak to the people who are corrosion engineers or corrosion scientists. And my one thing would be intolerant of corrosion. Be tolerant of corrosion. If we should never be having repeat leaks. Be intolerant of corrosion.
Very good, wise words. Thank you, Bill. And Claudia, what is that one thing that you would like to make sure everyone remembers?
So my experience is not that big, but I would say to don't be scared and think that try to be involved with organizations and be a proactive person in this, and you can get to this corrosion world from very different places.
Thank you again, and wise words from a young head. So well done. Thank you all panelists, but you've still got a job to do to answer some of these questions. So there are lots coming in. I will have to decipher some of these, but let's start with, I think someone wants to actually speak. Ben, are you able to?
Yeah, good morning.
Oh, good morning, Ben. Hi.
Hello.
So,
sorry, go on.
I was just about to say, Ben, it's good to have, you sound like a young person, and it's great that you know how to use the technology. You were straight onto the mic. If that was an older person, we'd still be saying, can you hear us? Can you hear us? So
yeah, I I'm not that young. I'm 35, but my colleague next to me is 25. So you've got 10 years between us. But yeah, we're classed as young, I guess, by some people.
You're still young. So Ben, introduce yourself first, and then question.
Yeah. So my name's Ben. I've got my colleague Toby with me as well. We're young engineers and pipelines craftsmen working for Southern Gas Networks.
Okay.
So our main role, we maintain the CP systems on our network. We inspect corrosion on the network as well. We look after sort of a broad range of bits and pieces. With regards to corrosion under installation, myself and Toby especially take on the role of doing a lot of above ground inspections on things like heat exchangers, pig traps, valves, alongside the vent lines and grease lines on them. And we find problems with corrosion under the lagging on the heat exchangers and also around clamps and clips that hold the grease lines and vent lines on. So our sort of question would be, firstly, how do we learn what's going on in the oil and gas industry? And also around what sort of technology that Corrosion Radar offer that can help us to monitor that without having to strip down everything and get underneath that lagging to look at it, rather than being able to monitor it sort of remotely, because a lot of our job is very much taking things apart to be able to inspect it, which obviously can be quite time-consuming.
Okay, so there's a lot there. This is a session about not necessarily Corrosion Radar's technology, but we can always take that offline. But I'm sure, Shiraz, you can say something on that. Bill, I'm sure you've heard this problem. It's interesting hearing it from SGN, gas networks. So what do you have to say?
Well, great question, Ben. We are still talking about CUI, so it is clearly a big problem, and it doesn't have any easy answers. In BP, we used to say corrosion is not for kids. Yeah, some of the panels have said it's multidisciplinary, and there's lots of elements to this, and CUI is a particularly tricky problem. You've just, there's no easy way to do this. You need corrosion engineers who understand CUI. You need to do clear risk assessments. You need to know where to look. You can't look at everything. Your point is absolutely right. And so you've got to use a sort of statistical type approach. Look in the places where you think it's going to occur. Use new technology. There is some great new technology available. There is no one silver bullet, right? You need to maybe use a myriad of different techniques, but you say this terrible, you need to spend some money on it. It's a big problem, and it needs money. I would also add one other thing, that we talk about CUI, but in many cases the fundamental problem is we don't put insulation on right in the first place. And we don't stop the water getting in. So I would say, for the people who put your insulation on, get them trained. And I'll make a plug. The Institute of Corrosion offers training for insulation applicators, but so do many other organizations as well. So, make sure your people are well trained in putting it on in the first place, and then have great corrosion engineers and inspectors to help you manage the problem.
That's interesting. Just Shiraz, from your perspective, from a technology point of view, picking on what Bill just said, does technology have a part to play as part of this holistic approach? There's no silver bullet. So how does technology assure companies like SGN that the installation has been put on properly, or where there is problems?
Yeah, I agree with what Bill said, and that's what we do every day, and that's what we hear every day from different industries. The application is the same. They have to insulate their assets, and unfortunately, insulation is not always put properly, and the coating is not always applied properly. So we have that risk of, and this is why CUI happened. If everyone done their job properly, we will not be talking about CUI. And this is what we are trying to solve with Corrosion Radar. As Bill said, it needs, because what we see sometimes, it's people want to carry on the same way, but solve the problem. You cannot carry on the same way, not spending any time and effort and hoping that the problem will be solved. And there is no miracles. So you need to look at them at what exactly you are trying to solve, and how much effort and commitment you are making into, because that will have an impact on your operation, will have impact on the safety of people, of the environment, a lot of impact. Maybe you will not be able to see it in the short term, but it will happen in the long term. So for us as Corrosion Radar, we try to walk with the customer through that journey step by step, because we know sometimes change is not easy. So we kind of, our approach is, let's start somewhere and we build it up step by step in solving this problem with you.
It's a balanced, considered approach, Shiraz. And it's not saying that one, you do data and technology and not the other. You need to be able to optimize all different solutions, as Bill said. And Claudia's nodding there. So any other people that want to talk? I don't know if it's anyone else wants to talk. Okay, Julia. Hi, Julia.
Hi, James. Hi, yeah, my name
I can just about hear you, Julia. So you might need to talk loud like me.
All right, is this better or?
Yes, that's fine. Thank you, Julia. And if you can introduce yourself and ask your question, please.
Yeah. So my name is Julia. I am a graduate materials and corrosion engineer, and I've been working for Wood for just under 2 years. So currently I'm doing a lot of CP stuff. So, and I really like the point of view from the talk today. It was very relatable for me as a young engineer. And I really want to ask how us as like students or young engineers can contribute to technological evolution of corrosion in general.
Okay, anyone wants to start with this question?
Well, yeah, I mean, again, great question. And then young engineers are just budding to, they've got so many great ideas. It's, when you get old like me and you get into your 40s and 50s, you're just not as enthusiastic maybe as you are when you're young. And so how do they get involved? I would say networking is the absolutely key thing. Get involved with your local corrosion societies. There are loads in every country. Get involved, share information. These places provide forums where you can talk more openly. Maybe, in days gone past, oil and gas companies would talk about their leaks, but then the world became dominated by lawyers and they almost don't talk about them anymore. And that's great, because there's a lot to learn from sharing information like that. But there are certain forums where things can be discussed in a little bit more freedom. So get involved, understand the problems and share your ideas would be my suggestion.
Thank you, Bill. Anyone else wants to?
Yeah, I would like to say that I totally agree with what just Bill said. And also that if you have the chance to go to a conference, for example, don't take it for granted and try to really create a network, a great discussion. Don't be afraid to ask senior scientists, because really, normally they are very kind and nice people, and they are willing to help young generations. So really take the opportunity of being in conferences very seriously, and open your research and your work to discussion with the people that are there.
Thank you, Marta. Excellent. There's lots of questions coming in, some that we will be able to respond by email that are quite specific, and there's some that I think would be good to raise. One I've noticed is from OGTC, who we know well in Aberdeen, and they've prepared an asset integrity roadmap. So in the mid and long-term planning, machine learning will be able to detect external corrosion, and artificial intelligence is suggested applied to predict internal damage mechanisms in the future. So how do you, on the panel, how do you see corrosion risk-based assessment 10 years from now?
I can start. I think risk-based assessment will benefit a lot from all the technological advancement that we have. And I think we're going to move from a static way of doing it to a much more dynamic, real-time way of doing it. So a lot of assumptions will be replaced by real data. So for me, that is very, that is an area where you will see a lot of benefits. And at the end of the day, it's all about risk management. And the more accurately you get that right, the lower your risk will be.
Understood. Excellent. Anyone else?
Yeah, I agree with Shiraz. You know, it's improving every day, risk assessments. Our understanding of corrosion mechanisms is improving all the time. I think I see much more automation in risk assessments, streaming live corrosion data, integrated with streaming live process data such as temperature, pressure, and corrosion engineers will still need to be involved. I cannot envision an artificially intelligent corrosion engineer that completely eliminates an engineer, but I can see these programs and processes really helping engineers to stop doing the things that aren't important and allow them to focus on the things that really are important. So I'm not frightened in any way by automation and artificial intelligence. I do see it as a great tool, but it will be a tool that corrosion engineers will be using.
Excellent. Yeah, and I presume, Bill, combined with social media, we don't need to use letters anymore. We can maintain those relationships with WhatsApp and and all these other cool things that young corrosion engineers will be using.
Yeah, even I can use some of those tools, James.
Excellent. Okay, let's quickly move on to, there is a question from Inez Kandam. Appreciates the discussion. And you're based in Iraq, so welcome. PhD corrosion control via inhibitor. My question is, there are numerous research papers about corrosion inhibitors, but limited of them are applied in industry, although it has high corrosion inhibition efficiency, if that makes sense. Sorry if I've ruined that, but is there any criteria for using inhibitors industrially? That sounds like a question maybe for you, Martin.
Honestly, I don't have no cause. I mean, my experience is in academia. I do like the first trials, and then the upscaling, everything is done by industry, not by us. I think that inhibitors, it is a huge work that depend totally on the material, on the environment. So I'm not pretty sure. My background, for example, is with inhibitors for light alloys. So in that, I would say that right now we are trying to change these inhibitors for a more green, environmentally friendly one. So yeah, there is a criteria, for example, for the use of these chromium conversion coatings for the aeronautical industry, and this is by standard. But the aim is, or our final goal is going to be to change this for more green friendly alternatives.
Okay.
But now that is not yet, for commercial application. It is just in the lab or upscaling stages.
Understood. Thank you. Lots more questions, which we'll come back to at a later stage. Someone's putting their hand up going, pick me. Stephen Tate, I recognise that name. Stephen, you got the mic?
You're on mute, Stephen.
Okay, can you hear me now?
Yes, there you go. Told you about this lag.
Sorry, there's just no. It's a fantastic discussion. It's great to hear all the contributions from all the young members of the panel and from the audience. I was just wondering if Julia's earlier question was geared towards in-house training and whether it was more to do with she wasn't getting the range of experience within the company, and that's why she needed to look outside of her own organization. if that's what she was meaning. But I know quite often, to some extent, you have to drive your own career. Others don't do it for you. You have to have your own plan, you know. So I wondered if that's what she meant. But,
so take the initiative, Stephen, is what you're saying, and look to organisations like EFC. We've got APEM, formerly known as NACE. We've got ICOR. So there's lots of resource and courses and training that is accessible. And Stephen, you're saying just get on with it and maybe take that information to your manager and say, right, I would like to invest my time in this.
yeah, very much. You have to set your agenda to some degree, but
Yeah, that's a very good point. It's a nice point to finish up on, because I'm conscious we're now at the hour mark, and there's lots of good questions, and thank you. We will attempt to answer some of those questions, such as corrosion radar for storage tanks. You know, that's stuff that you can contact corrosion radar directly. The answer is yes. So all these specific questions, we will somehow get back to you with the appropriate answers. So thank you. It's a Friday. The weather is up and down, but I think we've started the day in the right way. I think all this young energy and the energy transition is giving me certainly lots of motivation and wanting to be creative in how we approach COI. So thank you for the panelists, and thank you for everyone in the audience. It's been a really good session. So have a great day and stay safe and well.
Thank
All the
you.
best.
Thank you, James.
Thank you. Thank you.
Bye-bye.
Thank you.
Bye.